Hello everyone. Today we're going to be looking at confidence intervals, the basics. So hopefully you're watching this after you completed a activity about working with a couple of confidence intervals. So there are 4 main things that you want to know about confidence intervals, and we'll talk about those 4 big ideas as we go through this. But for right now, the first thing that you need to know is you need to know that the confidence interval is something that we use to estimate a population proportion, and to do that we use a point estimate and we add and subtract a margin of error. So for example, maybe you might say 5% of the population likes lemons. That would be our 5%, that would be our population point estimate. And then we would say plus or minus a margin of error of 3%. So this would be, for example, us saying, okay, we're going to make an estimate about the population and say, oh, we're going to estimate about 5% of the population likes lemons, but then we're going to add a margin of error to be a little bit more confident. That's why they're called confidence intervals. So the things that make up confidence intervals are a couple of key things. First of all is something called a point estimate. Now that point estimate is going to be made from a statistic. So a statistic that you calculate from a sample. So that statistic could be a p-hat, a sample proportion. It could be a sample mean. And it could be anything else that you calculate from a sample. The margin of error is what we're adding or subtracting to that. So let's zero in on this idea of a point estimate for a second. So we've got an example 1, and by the way, we are on page 4 of your notes packets. So in example 1, we have 3 parts where we're going to identify what we're using as our point estimator and what we're using as the point estimate. Now, what's the difference in the two? The point estimator is the statistic. So that's whether you're using, are you going to use p-hat? Are you going to use x-bar? It's whatever statistic you're using. And then the point estimate is the value, in other words, the number of that. So for example, example 1a, the makers of a new golf ball want to estimate the median distance of the new balls, will travel when hit by a mechanical driver. They select a random sample of 10 balls and measure the distance each ball travels after being hit by a mechanical driver. Here are the distances. And so I've gone ahead and reordered those distances so that they're in numbers. We have a random sample and we want to estimate the population median. Well, we have a sample here, so what we're going to use to estimate the population median, our point estimator, we're going to refer to that as our sample median. And we don't have a symbol for sample median, so we just write it out. I can get my N to pop on there. And then our point estimate would be the sample median from this particular sample. So if I look and try to find the middle, marking out, marking out, marking out, marking out. Okay, these 2 numbers are in the middle, so our point estimate would be 285. So if I were to use this number to start to make a confidence interval, then I would estimate the sample median, or the population median would be 285 plus or minus whatever I calculate my margin of error to be. And I'm going to abbreviate it MOE for margin of error, which will take a little bit more for us to calculate, so we'll get into that later. So let's go back to our point estimate. So part B, what proportion of U.S. adults would classify themselves as vegan or vegetarian? So that's what we're trying to estimate. We are interested in the population proportion. So the percentage of U.S. adults who would classify themselves as vegan or vegetarian. And a Pew Research Center report surveyed 1,473 randomly selected U.S. adults. And of these, 124 said that they were vegan or vegetarian. So if I'm interested in the proportion P, then that means that I am interested in population proportion P. So I want to know P, which means my point estimator is my sample proportion, or P hat. My point estimate is the number from my sample. So out of the 1,473, P hat would be 124 out of that 1,473. And if I change that to a decimal, I get about 0.084. And then in part C, the math department wants to know what proportion. So again, we're interested in population proportion here. So we want to know what our population proportion of its students own their own graphing calculator. So we take a random sample of 100 and we find that 28%. So we're interested in population proportion. That means to estimate that, we're going to use the sample proportion, our point estimator, and our point estimate would be the number. So 28 out of 100 would be 0.28. Okay, so again, the point estimate is the first part of what you need to calculate a confidence interval. So for the golf balls, we would start with that 285, add or subtract a margin of error. For the proportion of U.S. adults who would classify themselves as vegan, we would start with 0.084 or 8.4%, plus or minus whatever the margin of error we calculate later. And then if we wanted to estimate the true proportion of students who have a graphing calculator, we would first say, okay, well, it's probably 28% plus or minus whatever margin of error we come up with. So sometimes you'll be able to identify the point estimate by just seeing, oh, it's the first number that you add and subtract to. Other times, they will give you, let's see, where was it? A problem like this. And we'll come back to number 2 in a minute. So we have a poll. Now if you did the activity, you've already seen this question, so we're going back to it. But if you haven't done the activity, here we go. A poll of 1,015 American adults by the Gallup Polling Organization asked the following question. Would you vote for or against a law that would limit the size of soft drinks and other sugary beverages served in restaurants no more than 16 ounces? So they found some results. The results show that 30% of those surveyed agreed to a limit in soft drinks with a margin of error of 4%. So they had the 30% with their point estimate, and then they're going to add and subtract 4% to get the margin of error, or the margin of error is 4%. Okay, so then it says based on the results, which is the confidence interval. So we're going to take this 30 and we're going to add 4% and we're going to subtract 4%. So 30 plus 4% equals 34, and 30 minus the 4% is the 26. So our confidence interval is 26 to 34%. So sometimes you'll see a confidence interval written like this. Other times you'll see it written more like that. And you might even see it written in parentheses, 0.26 representing 26% to 0.34, 34%. Okay, so then sometimes you'll have to identify the point estimate from an entire problem. So going down to, I believe this is page 5. It's example 2 on page 5. And we're going to look at example C. Or example 2, part C of that. We'll come back and do the others in a minute. So we have 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on the poll, 95% of the interval for the population, based on the poll, the 95% confidence interval for the population proportion who favor candidate A is 0.48 to 0.54. So what we have to do on part C is we have to identify and calculate the point estimate. So we need to know what's in the middle. So you know how before we had this confidence interval and we got it from taking the 30% and adding and subtracting 4%. Now we are going backwards. We're going from the interval to figuring out what number we're adding and subtracting. So the way that we do that is we figure out what number's in the middle. So if I want to find the point estimate, I can figure out, okay, what number is in the middle of 0.48 and 0.54. One way you can do that is by averaging those two. So I can take 0.48 plus 0.54 and I can average the two. So grab my calculator. And I'm getting 0.51. So 0.51 is my point estimate. And then I have to figure out, okay, how much did I have to add to 0.51 to get 54? And how much did I have to subtract? So here we can do a little bit of mental math. So I can think, okay, well, if I take, let me grab a different color. If I take 51% or 0.51 and I add and subtract 0.3 percentage points, that will give me my margin of error. So the question is, what's the point estimate? Well, my point estimate is 0.51. What is the margin of error? The margin of error is 0.3. Hold on, let me check my math. It's not 0.3. It's 0.03. There we go. So 0.51 plus or minus 0.03. So my point estimate is 0.51 and my margin of error is 0.03. Okay, the second thing that we need to know about, go back to number 2, is that confidence intervals contain a plausible value for the unknown parameter. So you'll see that at the bottom of page 4, like what are confidence intervals? What exactly do they do? And so we want to make sure we highlight that. That's plausible values for the parameter. Now the parameter is what we're trying to estimate. So if we're trying to estimate the population percentages, it gives us plausible or possible or likely values for that. So for example, back over here where we were talking about the sugary drinks, we came up with, let me erase some of this extra stuff here, a confidence interval to estimate the percent of the population who agreed that a law should limit the size. So then we have this question. It says a congressman plans to write a bill which would limit the size of soft drinks, but he's only going to do so if there's evidence that at least 40% of adults agree. So he's going to write it if he thinks that 40% of his actual population proportion agrees. Or no, population, yeah. So if this congressman, 40% of all of his constituents. Well, the confidence interval says, well, probably only about 26 to 34% of the population agrees that a law to limit the size of sugary drinks should be made. So since 40% is not in that interval, we're going to say no, because 40% is not a plausible value or a likely value. Plausible, / likely value for the true population proportion. Okay, number 3. You will have different percentages of confidence levels. So, sometimes you'll see a confidence interval that will tell you, oh, I have a, let's pause for a second. So you'll hear confidence, different percentages. So 99% confidence, 95% confidence. And what that does is it tells you the capture rate for the population parameter. So I'm going to take you back to that activity that you did. Hopefully that you did. So here is a poll. A poll by CNN asked a random sample of 1,000 adults if they supported raising the minimum wage from $7.25 an hour to 15% an hour. Of those surveyed, so here's their sample proportions, 55% supported raising the minimum wage. So if we calculate something called a 95% confidence interval, then we see somewhere from about 51% to about 58%. But if we calculate an 80% confidence level, there, I notice I have a smaller width. I'm still centered at the 55% from before, but my margin of error is smaller. So if you're less confident, you'll have a smaller interval and your margin of error is smaller. So 90% is a little bit more confident than 80%. We have a wider interval and a little bit wider margin of error, and then 99%, 99% confidence. So notice they're all centered at that 55% point estimate from before, but we're just adding and subtracting a little more. So what does this percentage mean? It's the rate at which the interval captures the true population proportion. So what that means is that if we were to use this calculation to calculate the population proportion, we would get the actual population proportion about 80% of the time. Now, remember, 55% isn't the actual population. It's just what happened in one sample. And those numbers can vary from sample to sample. But if we want to really make sure that our calculations calculate the true population proportion, we'll use a 99% confidence interval. That if we were to calculate based on this calculation and this margin of error, we would get the actual population proportion 99% of the time. So you'll be asked to do a couple of things. You're going to be asked to interpret a confidence level and this is a script that's really nice for you to use to make sure you say all the right words, all the right things to get all the credit on every question. So if you're asked to interpret a confidence level, you're going to say, if you were to take many samples of that size from the population, approximately whatever percent confidence, so if your confidence level is 95, you'll enter 95 right there. 95% of the calculated confidence interval would capture, and then whatever you're trying to estimate. So, for example, is there one where we have to interpret? Yes, right here. Okay, so again, 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question: if a presidential election were held today, would you vote for candidate A or candidate B? Based on this 95% confidence interval, the proportion of populations who would vote for candidate A is 48.48.54. So when we interpret the confidence level, let's see if I can make this a little bit smaller. We would say, if we were to take many samples of, it doesn't say how many, does it? Of the same size from the population, and calculate a confidence interval for each sample, 95% of the calculated confidence intervals would capture, and then here's where I look for what I'm trying to estimate: population proportion who favor candidate A. So would capture the true population proportion of those who favor candidate A. Then the other thing you'll have to do is you have to interpret a confidence interval. So the way that you interpret it is with this script. You would say, we are whatever percent confident that the interval from the beginning to the end captures that. So here's what it would look like here. If we have to interpret the confidence interval, we would say, we are, and then I look at however percent confident we are in the problem, we are 95% confident that the true population proportion of people who favor candidate A is between 0.48 and 0.54. Okay, once we have those, now we have a couple of other ones, other parts. Part D. Based on this poll, a political report claims that the majority of registered voters who favor candidate A. So they're saying like most of the registered voters favor candidate A. Use confidence interval to evaluate. So what would majority mean? Majority would mean greater than 50%. Well, if I look at my confidence interval, is the majority in here? Yes, but 0.48% is also a plausible value. So both a majority is a plausible value and a non-majority is also a plausible value. So I would say that the confidence interval is the interval of plausible values for the true population proportion. Well, 0.51 to